Hello my dear all students, this is MathDOC. So during this session, I'm going to focus on quadratic functions. So quadratic function act major role in mathematics, major role in mathematics. So it is a polynomial type. It is one of polynomial type, quadratic function. So let's introduce quadratic function first. Okay, let's go for that. Let's go for that. Check this now. Okay, it is simple thing. Let's consider x to the power n type terms, x to the power n types terms. Here n, they are integers, positive integers with 0, and that create polynomials. Then x to the power 0, x to the power 1, x to the power 2. So by using these terms, we create quadratic functions. Then usually we define quadratic function general form as y equal ax squared plus bx plus c. This is quadratic function general form. General form. So here a, b, c values we call coefficients. Coefficients. So they are real values. They are real values. A, b, c, real values. So here we say quadratic function because its degree is 2. We call degree mean maximum power. Then degree 2, maximum power 2. Therefore, A, B, C real values. Therefore, this must be not equal to 0. A not equal to 0. A not equal to 0. That's how we say it is quadratic. So, if A 0, this term will disappear, then further that won't a quadratic function. But BC can be any real value. BC can be any real value. This is quadratic function. Actually, we have three different forms of quadratic functions. We have three different forms. So, example, you consider y equal x minus 1, x plus 1, x minus plus 2. This is we call factor form. Factor form. It has given two factors. So, we have another form y equal, when you expand this, x square plus x minus 2. This is we call general form. That is we call general form. And also we have another form y equal x plus 1 over 2 square minus 5 divided by 4. 5 divided by 4. This is we call vertex form. All three are same. Then here factor form, general form, vertex form. Here factor form. Here general form. And here vertex form. Vertex form. That is the specialty of quadratic function. So anyhow you identify for quadratic, there will be x square term. X square term. So these are we call quadratics. Quadratics. So the mother function of this type of quadratic, we say y equal x square. Y equal x square means its mother function. Mother function. So y equal x squared graph. Y equal x square. Remember always quadratic graph parabolic shape. Parabolic shape. Here x-axis, y-axis. Here parabolic shape graph. Concave up, parabolic shape. So y equal minus x squared, that also quadratic type. Then here x, y, its graph, parabolic shape, but that one concave down, here concave down, here concave up. So that happens with this sign of the leading term. If leading term sign is positive, that is concave up. When leading term sign is negative, then it is concave down. Concave down. So for quadratic function, definitely it has vertex. it has vertex, and it has symmetrical axis. So you consider y equal ax squared plus bx plus c type quadratic function. This is general format. Now you remember, when this term we call leading coefficient. Here this is leading term, its numerical value called leading coefficient. If this leading term coefficient positive, you say it has minimum shape function. So when a less than 0, then maximum shape function. Here maximum shape, here minimum shape. You can remember using here these two mother function. Okay, y equal x bar minimum shape, you just remember. You can plot them by substituting x values, no? But anyhow, you remember these two relations. Very important relation, number 1, here number 2. Okay, then always this quadratic tab has symmetrical axis, and it has vertex. It has vertex. Then this vertex we call it a turning point. These two are turning points. Vertexually turning points. Turning point. Here especially this one called local maximum point. Local maximum point. And especially this is called local minimum point. Local minimum point. That is quadratic. Okay. Then here I told you there are 3 different forms now. There are 3 different forms. Here factor form, by factor form, we can easily find x-intercepts. Here factor 0 values we call x-intercepts. Factor 0 values we call x-intercepts. Here by general form, we can easily find y-intercept. Here constant term we call y-intercept. Constant term we call y-intercept. Constant term we call y-intercept. By this vertex form, we can easily find symmetrical axis and the minimum or maximum point. Here, perfect square 0 value, that is x equal minus half, we call symmetrical axis. X equals minus half, we call symmetrical axis. Corresponding, here this value we say minus 5/4, local maximum or local minimum. But here x square coefficient plus, therefore we say this one local minimum. You remember, when x square coefficient positive minimum shape, when x square coefficient negative maximum shape, then this contain minimum shape function. So that is about quadratic function. Let's do few another examples. Okay. Now check this example. Y equal x minus 1 times x minus 2. It is quadratic type factor form. So we can easily sketch this. This is x-axis. Here factor 0 values 1 and 2. So when you expand this x square coefficient positive, then you sketch minimum shape. That is the sketch. Then consider y equal 1 minus x times x plus 1. Okay. Now that also given factor form. You consider x-axis. Here factor 0 value 1. Here factor 0 value minus 1. So when you expand this x square coefficient minus. When x square coefficient minus, then that has minimum shape, maximum shape. Here the function now. That's the function. Then within minus and plus 1 mid value, mid axis will be y axis. Here 1, 2 no, then y axis somewhere here. Then y equal 2x minus 1 x plus 1. You can sketch this one as well. Consider x-axis, here factor 0 value half. Here is factor 0 value minus 1. Then leading term positive. When you expand, it is positive. Then you sketch this way. Then y-axis somewhere here. Likewise, you can sketch. These are rough sketches, okay? These are rough sketches of quadratic functions. Let's do another example. Y equal 1 minus 3x, 2 minus x. Okay, let's sketch this. First, sketch x-axis. Sketch x-axis. Now here factor 0 value 1/3. Here factor 0 value 2. So when you expand, x square coefficient positive. Therefore, minimum shape function. Minimum shape function. Then y-axis somewhere here. So you can sketch according to scale. That's how we sketch this type of factor form quadratics. Factor form quadratics. Now let's see how to sketch vertex form quadratics. Vertex form quadratic. Okay, let's do that. Okay, now here you need to remember x square coefficient positive minimum shape, x square coefficient negative maximum shape. That is the thing. Now if you have vertex form, you need to consider purpose square 0 value first. Then when this one 0, corresponding y value is this. So that will be the vertex. That will be the vertex. Let's see it. You consider y equal a times x plus b, x plus p squared plus q. Here this is vertex form. Vertex form. Then here purpose square 0, x plus p equals 0, x equal minus p, symmetrical axis. Symmetrical axis. Then when x equal p, corresponding y value, when x equal minus p, corresponding y value is q. Then the point minus p comma q. Minus p comma q. This one we call its vertex. Its vertex. Then further we know a greater than 0 minimum shape, a less than 0 maximum shape. Likewise, we can get rough sketches. Now, consider y equal x minus 1 square plus 2. Here x-axis, y-axis. Here 0 value 1. That is symmetrical axis. Mark it. Then corresponding y value 2. Mark it. This will be the vertex. That is the vertex. Then leading term positive. Therefore minimum shape. Parabolic. You can sketch like that. Now here y-intercept you can find by substituting x equals 0. When x0 minus 1 square plus 2, that is 3. Then y equal x plus 1 square minus 3. Let's check this. Here x-axis, y-axis. Here 0 value minus 1. Symmetrical axis minus 1. Corresponding y value minus 3. Then positive. Then minimum shape. You get minimum shape, parabolic. When x equals 0, 1 square 1, 3 minus 1, 2. Therefore, that passes through 2, minus 2. Likewise, you complete the function. Y equal minus x plus 1 square plus 2. That also quadratic. Here x-axis, y-axis. Here purpose square 0 value minus 1. That is symmetrical axis. Then corresponding y value is 2. So here negative. Negative means it has maximum shape. Now before completing the graph, you find y-intercept, substitute x equals 0, 1 square 1 minus 1 plus 2, it goes through 1. Okay, this is a mind game. Okay, you can do all in your mind. Then y equal minus x minus 1 squared plus 3. Let's get. Then x-axis, y-axis, here 0 value we say 1, symmetrical axis, corresponding y value 3, this is vertex, here negative leading term, therefore maximum shape. Substitute x0 minus 1 square 1 into minus 1, minus 1, 3 minus 1, 2. It passes through to parabolic shape graph. Therefore, by factor form, you can find x-intercept easily. By vertex form, you can find vertex easily. By general form, you can easily get y-intercept. When x0, y value will be the constant. Then likewise, you can sketch graph. So, if the general form is given, you need to practice factorization to get this. You need to practice complete square method to get this expression. This method we call complete square. This method we call factorization. Usually, we can do always complete square technique for any quadratic function, but not for factor form. Factor form not always possible, but vertex form always possible. That vertex form we obtain by using complete square method. Okay, then that's all about introduction of quadratic function. Then next video we discuss about complete square method of quadratic functions. That's all about quadratic functions. You clearly get idea of quadratic functions because this is major part of mathematics. Then this is really important for you guys. Thank you for watching us.